Hey everyone, in this video we are going to solve a Leetcode problem that is a smallest number with all set bits basically. So let's read the question first. You are given a positive integer, positive number n, return the smallest number x greater than or equal to n, such that the binary representation of x contains only set bits. So basically in this question, you are given a number n and you need to return a value x. And that could be either greater than or equal to the value that is given, that is n. And the condition is that the value you are going to return, that is x, it contains only set bits. That is only one, not even zero or anything else. So let's take an example. So here example is given 5, that is the input n. So let's see here, n is given here 5. Okay, what you need to do, simply you need to return a number that is either equal to 5 or greater than equal to 5, which contains only set bits. So the binary representation of 5 is 1 0 and 1. Okay, so the thing is that you need to have at least, suppose in this question you are given that you can return the same number also, but it should contain the set bits only. So when it is possible, it is possible only when for example n is given 4. I think n is given 4, it could be. No, in that case also we are having only one set bits. In case of 3, we are having 1 1. Okay, so in case when n is given 3, then at that time you can return the number itself because all the bits are set bits. But in case where you have 0, so you cannot return the same number. You have to return at least the greater than number of the given number, but the set bit should be same. So let's see how we're gonna do this for this particular example in n equal to 5. Suppose the thing is we are clearly saying that in this particular place of 0, we need to fill 1. So 1 here, and if we will fill here 1, it will become the number 7. Why? Because this is 1, this is 2, and this is 4. I hope you guys know the binary representation of a number. So then only you can just solve this problem. So the number becomes 7. So the answer is particularly 7. So for solving this problem, we can follow the approach that simply we will count the set bits in this number first of all, and after that we will form a new number with the count of this particular set bits. So first of all, we will count the set bits. Count, we'll write from here only. Okay, count the set bits. Okay, count the set bits. After that, what you are going to do? We will form a number. Form a number, form a number having that much of set bit, that much of set bit. Okay, how much set bit it should be? It should be at least the number which are given on that particular amount. So after that we will check whether we are satisfied with the solution, that the new number which we have formed, the new number which we have formed is either equal to or greater than the original number. If it is, so return the original number. Return the new number, or the original. You can simply write return the new number. Why we are not returning the original? Because it could be possible that suppose that we are just forming the number with the set bits with the count of the original number, it could exceed. Okay, but it is practically not possible. So don't worry, you can either return here the original also. And in case if the suppose you have in the n, for the case n equal to 5, okay, the count of set bit were 2. So we are forming the number, so it becomes 3. Then 3 is not greater than or equal to 5. So what we are going to do next? Simply what we are going to do? Simply we are going to shift this particular number to the one position left. So the number becomes 110, and after that we will add 1 here. Okay, and we will take a or. So what it happens, this will be, this is or. Okay, don't confuse with the 1. Here it is 0, So here it will comes 1, 1, 1. So the number becomes 7. Okay. After this particular check, we will keep doing this particular thing, that with our new num, we will take our value with 1, and we will do 1 I, that will, I mean, we'll keep what we could say, we'll keep shifting the value 1, and we will keeping it with the or, so it will form a new number, and this will be our value, required value. So let's code it and understand that how it's going to be done. So first of all, we will going to count the set bits. That int set bit equals to 0 in the starting, and int new num. Okay, or we will do the stepwise. Okay, so simply for counting the set bit, what we could do, simply we can use the, built-in pop count method in the C++, or else you can do n and n minus 1. So it will remove the last set bit of the number. So how many times this step will execute, that much number of 1 would be in the original number. So we'll keep the count there. So we'll do while n is not equal to 0, or simply we could write n, and after that we could do that n equal to n, and I mean n and n minus 1, and after that we could do set bit plus plus. Okay, so this much number of set bits are present in our original number. So now we will form a number with containing at least this much number of set bits. So what we are going to do, simply we will take a new num, int new num equals to 0, and after that we will start for int I equals to 0, I less than set bit and I plus plus. And after that, what we are going to do, simply we will take a new num, that's the new num. And after that, what we are going to do, new num or with 1 left shift I. So what this particular number is going to do, let me explain you. So as we were having the count of set bit with value 2. So in a starting new num is 0. Okay, and our index value is starting with 0. So what we are going to do, simply our new num is 0 and 1 left shift 0. So 1 will be here only. So the number becomes 1. After that, the I will become plus plus. So again, this number is not 1. Here it is. We will subtract it. Okay. So we will need to keep the two set bits in our the new num. So our I plus will be happen. And after that, what we are going to do, simply we're gonna take this is our new num become this particular value. After that, again we will take a jar. Okay, we will take a jar with the 1 left shift 1. So it is 1 and it is 1 here, and we will take a jar, or value. So it will be here 1 and 1. So this particular value become 3, but this is not greater than or equal to our original value. So we will keep adding we will keep doing this particular thing until we will get a required value. So what we are going to do, and see, in this particular case, we are changing the n. So before doing that, in last, we will need to compare this particular situation, that whether the x is greater than or equal to x. So we'll keep a variable named original to store the original value. Okay. And after that, what we are going to do, simply we'll start int I equals to 0. Okay. Or here we can globally declare it also. What we could do, see, as here we have done int I now, we could do here only int I, so we can use it here only. If it is not done, so we will keep doing until our new num is not equal to original. Okay, after that, inside what we are going to do, repeat the same thing. And before doing that, we need to make a check that if new num is greater than equal to original. null. Okay, if it is, so return the new num, new, new num. Okay, and after that, what we are going to do? Simply after doing, I mean, adding one bit to the our new num, we will make a, this particular check that if it is done, so return the value. If it is not, then I plus plus. Okay, and in last, simply you can return any value. See, it is have a possible value, so you will get your answer in the while loop only. But for the sake of the need of this function, we can return any random value. Simply you can return one also. Okay, so what we are going to do, we will run this particular code and see whether we are passing our test case or not. Yeah, the test case is passed. We will run for the submit our solution. The solution is submitted. See, after we we have also one more approach that simply what we are he asked that we you need to return a number which having all set bits, and you just tell me that which number has all the number set bits. For example, we have a value 4, so the binary representation is 2 to the power 2. Okay, 2 to the power 2. So it's I mean the binary representation is this, and the number minus 1, what could be this? This is 3, and its binary representation is 1 1. So we came to a thing that the number, we basically need a number 2k minus 1. So this will have all the bits set. Okay. So in this particular case, what we could do, simply we could find out this particular number. We will start with x equal to 1. We will take a variable x and we will start with 1 and we will keep doing this particular thing. What we gonna do? So let's see here. We will take variable int x equal to 1, and after that, while our number x is less than how much n. If it is less than x, or then I mean if it is less than the original value, then what we are going to do, simply x left shift, I mean left shift 1, and what we are going to do, or it with particularly with value 1. Simply what we were doing here only, we were doing the same thing. What we were doing, we were keeping our original value around, and we were taking the key to the left side. So here what we are doing, simply we are taking our original value like this and ORing it with the 1. So this is the thing, and after that you will get your value, that is return x. And you might see that this could not result. So let's try that. So we will, as we are starting with x equal to 1 and n is given 5. So what we are doing, we are simply doing x left shift 1 and or with 1. What it happens? 1, I mean x left shift, what we are doing? 1. Every time we are left shifting one time. So x and we are storing also. So 1 left shift 1, what happens? It happens 1 and 0 there. And we are making a OR with 1. So here it will be 0, 1. So it becomes 3. So in the first case, sorry, I couldn't show you this particular thing, that in the starting 1 is less than 5. So we came with this particular operation. After that, the number x become 3. So again, 3 is less than 5. So again, the operation will happen. And the current representation of 3 is 1, 1. Again, it will left shift 1. So it becomes 1, 1, 0. And again, we will take a OR value. Okay. We will take a OR value. So here 1 will be included and the rest of the place is 0. After that, again, we will take OR value. So 1, 1, and 1. So this value becomes 7, and now the 7 is not less than 5. So this is our value, and we will return it. So this was the approach for solving this. So let's run this program and see whether it is running or not. Yeah, it's running. We can submit it also. Yeah, it's working fine. So I have shown you the two approaches for this particular program. You can find out other also. There could be a multiple ways for solving a particular problem. It's the time that how could you just evolve to solve this particular problem. So that's it for today. We'll meet in the next video with a new problem. See you there.